What if we told you that the calcium in your bones, the iron in your blood, as well as the gold ring that you might be wearing were all once part of a supernova explosion? That's right. Imagine a good fraction of the world just staying up and staring at a dead star, waiting for it to go completely dim. Well, that's exactly what might happen with the Betelgeuse star, because a dying star can be as exciting as anything else about space. If that happens, will we be able to survive something as serious as the Betelgeuse star explosion? Keep watching till the end to know more. We have already experienced at least 5 mass extinction level events that might have eradicated thousands of species of animals, plants, and sea creatures, and at least one of them could be caused by an extraterrestrial agent, like an asteroid that struck at the end of the Cretaceous period about 66 million years ago, which was responsible for wiping out dinosaurs. But apart from a meteor strike, Earth might have also witnessed another mass extinction event that could be caused by a supernova. Scientists estimate that on an average, about 20 supernovae occur in a galaxy like ours every 1,000 years, but we have only observed 5 in the last millennium. East Asian and Arabic records indicate that there were supernovae in 1006, 1054, and 1181 CE, while European records suggest the ones that occurred in 1572 and 1604. If you're somebody who loves stargazing, especially on a clear winter night, it would be extremely hard for you to miss the constellation Orion the Hunter, with his shield in one arm and the other arm stretched high into the heavens. At the same time, you'll also notice a bright red dot called the Betelgeuse, and the star's strange dimming has captivated sky gazers for thousands of years. Astronomers have been gathering all the data from NASA's Hubble Space Telescope and several other space observatories, and they concluded that the bright red supergiant star Betelgeuse quite literally blew its top in 2019, losing a substantial part of its visible surface and producing a gigantic surface mass ejection. This behavior was never observed in a normal star before, even though our sun routinely blows off parts of its tenuous outer atmosphere. Astronomers now understand that the Betelgeuse's difference in brightness might be because it's a dying red supergiant star with a diameter at least 700 times larger than our sun and might explode as a supernova and will give humanity a celestial show before entirely disappearing from our night sky forever. Does this mean that Betelgeuse has reached the end of its life? Will we be able to survive a star explosion? Well, astronomers are still uncertain about how a supernova would affect our planet, but as of now, they are of the opinion that life on Earth will be unharmed. But that doesn't mean that the effects will go unnoticed. It will shine as bright, at least 9 times fainter than the full moon, for more than 3 months. And all of this brightness would be concentrated into one point, and this incredibly intense beacon in the sky that would cast shadows at night. The surprises don't end there either. You could also see this during the daytime. So obviously, this would instill curiosity in everyone around the world as to what exactly is it that they see in the sky for at least a year. And it will also be visible at night with the naked eye for several years, even after the supernova aftermath dims. By the time it fades completely, Orion will be missing its left shoulder. The good news is that there is no need to worry about this stellar explosion because the supernova has to happen extremely close to Earth for any radiation to harm life, and luckily, Betelgeuse is far outside that range, as it is at least 724 light years away from our planet. But it does not mean that we won't be affected in any way. Many animals that use the moon for navigation are already confused by artificial lights, so another object as bright as the moon in the sky could be disruptive. Not only wildlife, even astronomers themselves will have a really hard time when making observations, because now they have to deal with 2 bright objects in the sky. This means that there won't be any dark time for a while. Even studying the Betelgeuse itself would be a huge challenge because the bright light would overwhelm all the instruments that we have today. To know more about this explosion, we need to understand what exactly a supernova is. A supernova occurs when a star destroys itself so completely that it can outshine the combined light of an entire galaxy. Yes, you heard right. In the last 1,000 years, only 5 of these events were visible to the naked eye, and all of them occurred before the invention of the telescope. We know about supernovae from their appearance in other galaxies, and from remnants left behind in our own galaxy. The best way to study supernovae would be if they appear near us so that we can learn more about them using the modern telescopes and technology that we have today. So what happens when a supernova erupts? Well, it will spray the cosmos with heavy elements, so observing one nearby would provide us with so much valuable information about the creation of matter in our galaxy. Most elements heavier than oxygen were created in a supernova before being hurled across space. These atoms supply the galaxy with materials essential for supporting life. The most common type of supernova occurs when a very large star runs out of fuel, halting the nuclear fusion process that keeps it bright. The star's outer layers fall inward, and protons and electrons are crushed together to form neutrons that will then be packed into a super dense ball. Matter will continue to rain down on this neutron ball before bouncing back, which would then result in a shock wave that destroys the entire star. All that is left behind would be a neutron sphere that is so dense, a matchbox of it would weigh about 3 billion tons. If the original progenitor star that led to supernova was particularly large, this neutron star would become so heavy that it would form a black hole, and nothing can escape from it, not even light. With the Betelgeuse star, you are looking at a core collapse supernova, as it can unleash more energy than our sun will release over its entire 10 billion year lifetime. If a star in our galaxy, too distant to be seen by the naked eye on Earth, becomes a supernova, it will certainly shine so bright that it could be seen in daylight. But then, you might be thinking, if the supernova is so bright, why have we only witnessed just 5 in the past 1,000 years? There must be more than that, right? Well, our galaxy is like a flat plate, and our solar system is just about 2/3 of the way towards its edge. So when a supernova occurs on the other side of the plate, it will be simply obscured by all the dust and stars that lie at the center of the galaxy. Astronomers have ever since observed supernovae in other galaxies and studied the remnants of those that occurred inside our own galaxy. This also includes the glowing filaments of the Crab Nebula, the remains of a supernova that lit up the night skies in 1054 AD and has been spreading across space ever since. The galactic debris like this would reveal the enormous destruction that can be caused by a supernova. But astronomers also argue that these stellar convulsions are an important engine of creation, apart from spraying the cosmos with several heavy elements on which life depends, as it also plays a key role in planet and star formation. A supernova will send shockwaves across the galaxy, and these dry clouds of gas and dust in space, compressing them so that protostars form at their centers. Eventually, nuclear fusion begins igniting a star's core of hydrogen, and it starts to shine. Planets form and orbit the star, which could also be how our sun and solar system came into existence. But you should only worry about a supernova only if it occurs about 60 light years from Earth. If that happens, its intense cosmic ray could destroy our protective ozone layer, which would allow increased levels of harmful ultraviolet radiation from the sun. With the Betelgeuse star explosion, you don't have to worry about anything, as it will take more than 100,000 years to explode. If that is the case, how did astronomers observe change in brightness with the Betelgeuse star? Well, there are several reasons why the Betelgeuse brightness could be fluctuating. As nuclear fuel runs out near the end of their lives, red supergiant stars start to bloat and form growing envelopes of gas and dust. And when this envelope gets bigger, this brightness grows. Supergiant stars are also known for their enormous convective cells on their surface, like a much larger version of those on our sun, where turbulence makes hot material rise from inside the star. Once it reaches the surface, the part of the material that erupts violently into space, like a giant radioactive belch, which can temporarily change the brightness. In the end, Betelgeuse provides a great setting for astronomers to study the last stages of a nuclear burning before it explodes, so that we can prepare for ourselves to face a supernova about 100,000 years from now.